Next step in our process is to do the variance covariance matrix. The variance covariance matrix, these are used in a lot of different settings, basically all over finance. Like your intro finance course as a PhD student and probably even as a master's student often includes a variance covariance matrix. Part of it is that algebra done by matrix notation is a lot easier to do. Here in Excel, it's not as important, but we're going to go ahead and set one up because it makes stuff easier. And usually the way that this works, let me move this over. So we have, and let's copy the companies down here. And turn the borders off. Usually what happens here is the diagonal, well, it's harder for me to show you here, but the diagonal of this is the variance. So this is how CVS varies with itself, which is the variance. And that is just going to be this number. The way that Microsoft varies with itself is this number. It's the variance. Chevron is that number. The question is, how does CVS covary with Microsoft? Well, that's this number. And if you notice, it's also this number. Same thing, CVS and Chevron, the covariance is this number. CVS and Chevron, the covariance is that number. And finally, the covariance of Microsoft and Chevron are these numbers. This is a standard way of expressing these covariances. Notice it's a symmetric matrix. So a lot of times you only need to calculate half of it in order to have the rest. Well, all times you only have to calculate half of it. But it's just super useful in terms of figuring out what the expected return on the portfolio will be. Okay, so the next step is to figure out our portfolio weights. And I'm going to put 0.6, 0.4, and 0. These are the ones that are given in Professor Hall's slides, and I'm going to make it blue just so you have it. And note, like, so if you're working in an analyst job, a lot of times they make inputs blue. I think I mentioned that in earlier classes. It's optional. In theory, like, these would also be blue. Oops, blue. And you could play around with these and see what would happen to your return in different states of the world. Here, we already were given that. It doesn't matter if it's blue, but we're going to do the weights. Okay, so now we do a weight matrix. And we are basically going to do almost the same thing, except, oops. The weight here is just going to be 0.6 times 0.6. The weight here is going to be 0.4 times 0.4. And the weight here is 0, but we're going to go ahead and fill it in so that we have it. Well, this weight is going to be that times that. Since it's a symmetric matrix, we can make that that. Chevron, the weight is 0, and CVS is that. 0.4 times 0. Okay, now we have the weight matrix. The second to last step on this is to get the portfolio return matrix, and that's just going to be the weight matrix times the variance covariance. So what we have here is a portfolio return matrix, and this kind of gives us an idea, given our weights and given the covariances and given the variances, what we would expect to the return to be on this asset or on this typical portfolio. And finally, we calculate the expected return, which is expected return times the weight on these. You can also add all of these. I'm sorry, that's not the right number. You can actually add those to get the standard deviation. All right, let's do the expected return, and then we will talk about the last part. All right, expected return 12.48. That's exactly what we got earlier. Expected portfolio variance is going to be the sum of all of these, and then the standard deviation is going to be that to the 0.5. And let me just put in parentheses risk. Variance is risk. Standard deviation is also risk. It depends on how you want to think about it. So intuition, end of the day, sort of what I want you to take home from this. The expected return on this portfolio is a function of the weights. So we bought 60% of our portfolio in CVS and 40% in Microsoft, and we multiplied it by our expected return for each of those assets. The standard deviation, or the risk, is the sum of the variances and covariances multiplied by the weight matrix, which is the weight squared. So you have to do it, well, squared basically. It's not 100% squared. What you're doing is multiplying the weight for these assets across the matrices so that you properly weight the variance and covariance. When you do that, you can sum the entire matrix and you will get a number. And when you take the square root, you'll get the standard deviation, which is considered the risk of the portfolio. So again, notice that we have the 12.48% expected return and the 16% variance for that asset, which is exactly right there.